Hello, geometry. Some more logic. As you look at the board, you'll notice that we have some new things on there. One of the big things is we have deductive reasoning. And the two statements that we have are the law of detachment and the law of syllogism. And we're going to talk more about those as we go through this particular video, this lesson on it. But what you have to realize is we are getting away from the original type of logic that we had when we started this unit. When we started this unit, we were using inductive reasoning. Do you remember what inductive reasoning is? Well, let's go back and find out. Inductive reasoning was using a number of examples to reach a plausible generalization or prediction, or you can say to get to a plausible conclusion based off of what we saw. Inductive reasoning is based on observations. What did you notice? What do you know? That type of stuff. When we look at deductive reasoning in comparison is a process of using facts, rules, definitions, or properties to reach a conclusion. So instead of just saying, hey, it looks like it, deductive reasoning says you got to prove it. You got to show it's true in all cases. You have to use the facts. Now, one of the ways we do that is called this law of detachment. It goes back and it uses our conditional statements or if-then statements. It uses our logical statements of P and Q just being true or false statements, but it goes a little bit beyond that. So let's look at the law of detachment here. I've got too much stuff on there. Now let me do it this way. Oops, do that up there. Okay, a form of deductive reasoning that is used to draw conclusions from true conditional statements is called the law of detachment. Now, the law of detachment, in simple words, is if P implies Q, or if P then Q, is a true conditional statement, and you know the P, the hypothesis, is true, then Q also has to be true. So what does that mean as far as our logic symbol goes for making truth tables? We have P implies Q, if P, if then Q, and P, so they both have to be true for this to be true, then that's going to actually mean that Q has to be true. So here's an example here, and you're going to have problems like this on your assignment. We need to determine whether or not this statement is valid based on the given information. If not, we're going to write invalid. And then we have to explain our reasoning. Well, our reasoning is going to have to be, it's the law of detachment. Basically is what it comes down to. So we are given that the measure of angle, sorry, we got a sentence here. Almost missed that sentence altogether. Our if-then statement is right here. If the sum of the measures of two angles is 180, then the angles are supplementary. That is our if-then statement. That is our P implies Q. So the P is the sum of the measures of two angles is 180. That's our hypothesis. We're implying our Q, our hypothesis, or sorry, our conclusion, then the angles are supplementary. So now we're given that the measure of angle A plus the measure of angle B equals 180. We are given two angles whose sum adds up to 180. We have that first spot. So then it says, hey, that means your conclusion to this is that the angle A and angle B are supplementary. This is a valid conclusion. And the reason for it is the law of detachment. Basically is what it is. Let's try another one. See if we can really get this down. Okay? Measure of angle ABC is 95 degrees, and the measure of angle DEF is 90. Angle ABC and angle DEV are supplementary. Well, let's see. According to our if-then statement, if two angles add up to 180, then we know the angles are supplementary. In this case here, I've got two angles. I got 95 plus 90. I've got 185. So this is invalid reasoning. It's not supported by fact. One more example. Given angle 1 and angle 2 are a linear pair. Conclusion, angle 1 and angle 2 are supplementary. Well, let's think about that. If angle 1 and angle 2 are a linear pair, and I draw that out, so I got a line, I've got angle 1 and I got angle 2. So if I take the measure of angle 1 and I add the measure of angle 2, I get a line, and a line measures 180 degrees. And our conclusion would then be, if I had two angles that add up to 180, the angles had to be supplementary. So this is a valid conclusion, and that conclusion is based off of the fact that a linear pair, they make a line, which means we can use the law of detachment. So for the law of detachment, you must have an if-then statement. And it has to be a true one. And you must have something where the hypotenuse is given. The hypothesis is given. So, I must have an if-then statement that is true, and I have to be given the hypothesis. So in my stuff, I have to be told that I am given a hypothesis. If that's the case, the conclusion is the result. Whatever the conclusion of your statement. That's the law of detachment. Now, on the flip side, we got this thing called the law of syllogism. And according to the notes in the book, it's similar to the transitive property of equality. If you think back when we talked about the transitive property of equality, it was something along the lines that if A equals B and B equals C, then A must equal C. That was the transitive property of equality. And I know we talked about it. So, the law of syllogism is similar to that. So our key concept here is, if P implies Q and Q implies R are both true conditional statements, then P implies R is also true. So another way of saying this, if a hypothesis, then a conclusion, and if that conclusion, then a new conclusion are both true statements, well, then if the hypothesis, then the new conclusion is true also. So the way we write that out as in our symbols, so we have our P implies Q and Q implies R. So this, we're setting up our truth table. We have to have both truths there. Implies P implies R. So let's take a look at an example here. Oh, that was weird. Okay. Use the law of syllogism to determine whether a valid conclusion can be reached from each set of statements. If a valid conclusion is possible, write it. Okay, can we get a valid conclusion? So, our first statement is, if two angles are complementary, then their sum measure is 90 degrees. And if the sum measures of two angles is 90 degrees, then both angles are acute. So, what I look for here is the conclusion of one part the hypothesis of the next part? And I got that a bit too far there. Is the conclusion of one part the hypothesis of a new part? If that's the case, then we say yes, we have some valid reasoning here that if two angles are complementary, excuse me for that cough, then both of the angles are acute. So if we have a situation like this, then I can use the if from the first statement and the then from the second statement and skip the other part altogether. That's the way this law of syllogism works. So let's try another example. If the heat wave continues, then air conditioning will be used more frequently. If air conditioning is used more frequently, then energy cost will be higher. So again, I'm looking, is the conclusion of one of these statements the hypothesis of the other? Well, I got air conditioning being used more frequently as a conclusion, and I've got air conditioning being used more frequently as a hypothesis. So our valid conclusion would be, if the heat wave continues, then energy costs will be higher. So, the law of syllogism. Notice it does tell us that we're looking for two true statements for this thing to work out. Now, let's go on to something new here. Extend that, drop that down, there we go. So, determine whether statement 3 follows from statement 1 and 2. Use the law of detachment or the law of syllogism. If it does, state which law was used. If it does not, write invalid. So there's our direction. Our first statement is, if it is Tuesday, then Marla tutors chemistry. And the second statement, if Marla tutors chemistry, then she arrives home at 4 p.m. So our third statement is that if Marla arrives home at 4 p.m., then it is a Tuesday. Well, let's see if that flows from the law of detachment or the law of syllogism. The law of detachment said I had to have a P implies Q, and P is true. Is that what we have here? Well, we had a true and false statement in number 1, so that could work for the first part, but the second part did not say anything about it being Tuesday. So it is not a law of detachment. Okay, so is it the law of syllogism? Well, the law of syllogism is, do I have the conclusion of one part being the hypothesis of the next? Well, I got Marla tutors chemistry, and I got Marla tutors chemistry, so that is looking real good. And then the next part would say that I'd have to start with if it is Tuesday and end with then she arrives home after 4 p.m. But that's not the way statement 3 is written out. So we have to say this is an invalid conclusion because it's not going the right way. Let's look at this last problem. If a marine animal is a starfish, then it lives in an intertidal zone of the ocean. And we're told that the intertidal zone is the least stable of the ocean zones. So we have this last statement here then, if a marine animal is a starfish, then it lives in the least stable ocean zone. Is that a valid conclusion? Well, as I look at that, I think, okay, do I have a law of detachment or a law of syllogism type problem? Well, I notice this second statement is not in the if-then form. What if I put it in the if-then form? And I would say, if an animal, or a marine animal, I should say, lives in the intertidal zone, CAL zone, then it lives in the least stable of the ocean zones. Okay, so now I have it as the if-then statement. Now, with that being the case, I can do my look for information. Again, law of detachment says I have to have an if-then statement and then be told that I have the hypothesis. That's not the case. I already see that in 1 and 2 that I have 2 if-then statements. Now, when I look at it, is the conclusion of 1 the hypothesis of the next? No. The 1 says lives in the intertidal zone of the ocean, and the one that we rewrote says an animal lives in the intertidal zone of the ocean. Ooh, there was some bad typing there. Don't know who wrote that up there. Okay, so we have that case scenario set up, which is what we want, which would mean we could use the law of syllogism if this works and say that if a marine animal is a starfish, well, then it lives in the least stable zone of the ocean. Now, if the highlighted green is what's number 3 is, this is a law of syllogism, and when we look at it, if the marine animal is a starfish, that matches right up here. So the marine animal is a starfish, matches to what we set up here, and then it lives in the least stable part of the ocean, which is what we have here. So this is a law of syllogism type problem. So we have the 2 laws. As we look at them more closely, The law of syllogism has to have a P and implies a Q, and a Q to an R, getting us to a P to an R. Has to be in that order. The P has to come first, the R has to come second. That's not a very good R, and I wrote a P. Where the law of detachment, again, is P implies Q, and we know P. So that must mean Q is our conclusion. Those are the two laws that you have to be able to work with today. They're the basis of really getting deductive reasoning going for us. Now, what are you going to do for the assignment? The assignment is a number 28. At least this year it is. It's page 85, and it's 12 through 29 all. And it's going to be a lot like what we just did. Is it the law of detachment? Is it the law of syllogism? Is there a valid conclusion? Good luck on your deductive reasoning.